Okay, so we're back in chapter 2. We're beginning chapter 2. Functions. And functions can be defined by graphs, tables, and formulas. And so we'll look at what a function is and how you can depict it. And so this is the basic rule of what a function is. A function is a rule that takes numbers and turns them into other numbers. Right? So that's so vague it's almost not useful. But we can make it more precise in a number of different ways. It's actually a really important idea in mathematics. So we can present functions in three ways that you probably see. And what are those? Well, you can tell from the title that it's probably graphs, tables, and formulas. We'll start with a table. And you've seen these before. Right, just a little table of x's and y's. Right, so say minus 2, minus 1, 0, 1, 2 for your x's, and suppose the y's are these numbers. Right. We usually call the x's the domain and the y's the range. These are the numbers that you put into the function, that's what the domain is, and the range is the numbers that the function gives back to you. So you give the function minus 2, and it gives you back 4. You give it minus 1, it gives you 1. You give it 0, it gives you 0. You give it 1, it gives you 1. You give it 2, it gives you 4. Right? So the idea then is a function. You give the function a number, and it gives you back a different number. Well, not necessarily a different number, but it gives you back a number. So that's one way to look at it. A graph, that's a second way to look at it. And so suppose we set up our x-axis and our y-axis. And remember that x is domain and y is range. So, minus 2, minus 1, 0, 1, 2, these are all numbers. Right? Here, 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 those are all numbers that are in my domain. And, let's see, my y's go up to 4, right? 1, 2, 3, 4. So, numbers in my range, 4, 1, oops, that's 1, and 0. So x equals minus 2, y equals 4. 1, 2, 3, 4. That corresponds to this point. X equals minus 1, y equals 1. That would correspond to this point. X equals 0, y equals 0. That's here. X equals 1, y equals 1. X equals 1, and then you go up 1 to get y equals 1. X equals 2, y equals 4. 2 over, and 1, 2, 3, 4 up. And that gives you y equals 4. So this is the same data in the table and in the graph. If x is minus 2, then y is 4. If you give the function minus 1, it gives you back 1. If you give the function 0, you just sit there and it gives you 0. If you give the function 1, it says y equals 1. If you tell the function x is 2, then it'll tell you that y is 4. So you read a graph by starting on the x-axis, going to the point on the graph, and coming back. And you can tell what this function is, probably. It's y equals x squared. Not easy to tell what the domain and the range is here from the formula. If you have a graph or if you have a table, it's not too hard. But if you just have a formula, it's not that easy. We can actually fill in the whole graph of y equals x squared. So, if you say, well, if x is 3 halves, which is 1 1/2, what's y equal to? Well, y is equal to 9/4. And that's that y value. So, to go from an x value to a y value on a graph, you start on the x-axis, you go up to the point on the graph, and then you go over, and then read off the number there. So you can think about what the domain and the range are in terms of the graph. A number is in the domain if you put a vertical line through that x value and it intersects the graph. Or just hits the graph. So 3 halves is in it. In fact, for this function, all x right? All real numbers, right? Because this graph goes off to infinity, both to the left and the right, so no matter what number you pick, eventually, even if you have to go way off the screen, you'll hit the graph. What about in the range? Well, range is a number that the function gives back to you, right? So if you give it 1, it'll give you back 1. If you give it 3 halves, it'll go back 9 fourths. If you give it 2, it'll give you back 4. If you give it 10, it'll give you back 100. So how can you tell if a number is in the range? Well, if I pick 4, is that in the range? Well, sure. If I look at this horizontal line, it hits the graph in 2 points, here and here. Right? So x equals 2, if I give the function 2, it'll give me back 4. If I give the function minus 2, it'll also give me 4. So if the horizontal line hits the graph, and here, that's only y is greater than or equal to 0. Because if I take, say, minus 2 down here, that's y equals minus 2, and I ask myself, well, what x can I give the function to give me minus 2 back? Well, this horizontal line never ever hits the graph. It's below the graph. And so there's no way the function can give you minus 2 as an answer. There's no number you can give it so that it gives you back minus 2. It can only give you back numbers y greater than or equal to 0, like 1, for example. Okay, so domain and range. Domains are the numbers that you give a function. The range is the number that it spits back. So basic ideas. And you can read a graph, right? Start at a particular value, you go up to the graph, particular x value, you go up to the graph, and tells you what the corresponding y value is. So those basics about graphs. Key idea about a function. Each x you give the function produces only one y value, right? So these are bad examples of things that are not function. Suppose you had a table that looked like this. This is my x's, these are my y's. Remember, x's are the domains, these are the numbers that I give the function. Y's are the range, those are the numbers that I get back out. Suppose I actually had to include 2 entries for minus 1 and 2 entries for 2, because the y values I get back out are 4, 3, 1, 1, minus 2, minus 4, and 5. And look at that and say, okay, well, what's going on here? Well, if I give the function minus 1, it says, well, do you want 3 back or do you want 1 back? I can give you either one. If you give the function 1, it says, well, do you want minus 2 or minus 4? We can try and graph this. Right? Here's my x-axis, here's my y-axis. We'd have minus 2, we'd have minus 1. That's my y-axis. And 0, of course, and 1 and 2. If x is minus 2, well, we need to go up to 4 and down to minus 4. So if x is minus 2, y is 4, so 1, 2, 3, 4. There's a point. If x is minus 1, y could be 3, that would be this one. 1, 2, 3, x equals minus 1. Or x could be 1, that would be that one. If x is 0, y has to be 1. If x is 1, then y is minus 2 or minus 4. And if x is 2, then y is 5. And the problem is these 2 points, right? Above minus 1, there's 2 separate y values, and below 1, there's 2 separate y values. So if I tried to graph this, what would I get? I'd have to have something that comes through this top one and have to come back to go through here, and then I'd need something that has to double back and then go up there. And what's the problem? Well, if I look at the vertical line through x equals minus 1, the vertical line hits the graph twice. Functions don't do that, right? So it's not a function. A function gives you out exactly one output for each input. That's why functions can be very useful in modeling all sorts of things that happen. If you make a certain number of cups of coffee, you have a very specific cost. You don't want to be saying, well, I'll make 17 cups of coffee, but it might be $20, it might be $21, I don't really know because, I don't know what's going on. A function will say you make 17 cups of coffee, it's 20 bucks. That and that alone. Okay, so now formulas and domains. It's a little hard to figure out what the domain of a function is from the formula, but there's actually a very nice rule for what we're doing in this class. So all functions in this class have domain all reals except in three cases. One, square root of x, fourth root of x, sixth root of, not x6 there, but 6 out here, sixth root of x, even roots. Because you can't take the even root of a negative number, right? So you can't take the square root of a negative number. You can only take square roots of positive numbers and 0. So the domain of square root functions are only positive numbers and 0. Second rule, natural logarithm, base 10 logarithm, or in fact any logarithm. And we'll see logarithms when we get to section 2.4. You can't take the logarithm of a negative number or 0. So there's the domain is x greater than or equal to 0. And 3, the third exception is you cannot divide by 0. And so if you have a function that's got a fraction in it, you better make sure that the denominator is never equal to 0. So we can do some examples of this. Suppose we have a function f of x equals to, say, square root of 2x minus 3. If we have the square root of something, whatever it is, has to be greater than or equal to 0. So to find the domain of a square root function, take whatever's inside the square root and say, well, that has to be greater than or equal to 0. And that is x greater than or equal to 3 over 2. So for this particular function, the only numbers I can plug into it are numbers that are bigger than or equal to 3 over 2. If I take anything less than that, I'll end up with a negative inside the square root. So 1, for example, 1 is less than 3 halves. If I plug it in here, I get 2 minus 3, that's minus 1. Can't take square root of minus 1. So square roots, the thing inside the square root has to be greater than or equal to 0. Another example, suppose we have a function. Well, we'll stick with the 2x minus 3, but we'll put x squared plus 6x plus 8 in the denominator. 2x minus 3 by itself, no problems there, right? It's not a logarithm, it's not a square root, it's not in the denominator. The x squared plus 6x plus 8, though, that is a problem. If I factor that denominator, it's x plus 4 times x plus 2. And so I can't have x equal to minus 4 because that will make this term 0, and I can't have x equal to minus 2 because that would make that term 0, and I can't have 0 as my denominator. I can't divide by 0. So here, the domain is all x except for, or all numbers except for x equal to minus 4, x equal to minus 2. These two numbers are bad numbers. You can't use them. And finally, a third example, just to be a little bit careful about, f of x equals 1 over x minus 4 times the square root of x plus 2. So there's a couple things going on in this one. First off, we have a square root that's in the denominator, and we have this x minus 4. So we know from x minus 4, you can't have x equal to 4 in this function, because then you'd be dividing by 0. Likewise, from this, you can't have x equal to minus 2, because if you have x equal to minus 2, that would make the thing inside the square root 0. Square root of 0 is 0. Can't have 0 in the denominator. But also, the thing inside the square root, the x plus 2, that's got to be greater than or equal to 0, because otherwise the square root function doesn't work. And so that means x has got to be greater than or equal to minus 2. So putting all this together, what does that mean? The domain is all x greater than minus 2 except x equal to 4. So from the square root, we get x greater than or equal to minus 2. From the fact that the square root is in the denominator, that means we have to throw out the minus 2, which is going to change this less than or equals to a greater than. And we can't include 4. And 4 is actually greater than minus 2, so we have to explicitly write out except x equals 4. Great. And so that's formulas and domains. 3 things to watch out for: root functions, logarithms, and dividing by 0. Any other function, if you're asked what the domain is, it's all numbers. Okay, the last thing to do in this section is a little bit about functional notation. Usually we'll see things like f of x equals x squared plus 3. There's a classic formula. Technically, there should be parentheses around that. And the thing about functions is that it's an equation. If you plug in for x on one side, you have to do it on the other as well. So f of x equals x squared plus 3. What's f of 2? Well, that means I took this function, this left side of my equation, and I replaced the x by a 2. Well, if I did that on the other side, on one side, I have to do it on the other side. 2 squared plus 3. Right? So if I replace this x by 2, I got to replace that x squared by 2, and that gives me 7. And if I want to know what f of minus 1 is, well, I replace this x by minus 1. That means I have to replace this x by minus 1. I get minus 1 squared plus 3. And that's equal to 4, because minus 1 squared is 1. Okay, so we can also do this replacement thing with other functions, actually. So suppose f of x is one function. In this case, we'll just stick with the x squared plus 3. And we have a different function. And we have to use a different letter than f, so we'll call it g of x. And that's 2x minus 1. So these are rules. This rule says if you give me x, I'll square it, add 3 to it, and give it back to you. The rule g says, well, if you give me x, I'll double it and subtract 1 and give it back to you. So, what is f of g of x? What is this saying? Well, we're going to give to the function g of f of x, we're going to give it the function g of x. So what we've done then is we replace this x here with the g of x. So what we want to do on the other side is to replace this x in the formula for f of x by this entire thing, all of g of x. So 2x minus 1 quantity squared plus 3. So we just replace the x by g of x and replace the x on the other side by the formula we have for g of x. And if you multiply that out, that becomes 4x squared plus 4x plus 7. Oh, no, sorry, plus 4. Because when you square 1 minus 1, you get 1, and then plus 3, and that gives you 4. So 4x squared plus 4x plus 4. That's what happened when you plug g of x into f of x. If we go the other way, g of f of x Now I want to take the formula for f of x and put it into the x in g of x. So this is 2 times, well, whatever you gave the function g of x. What did we give the function g of x? We gave it x squared plus 3. So this is my x squared plus 3 minus 1. So that becomes 2x squared plus 5. And so that's some basics about functions and functional notation. And domains from formulas, how to set up graphs and stuff. And that's essentially a lot of stuff that's